In yesterday's lecture we talked about finding the points of intersection when you had a curve and a curve. Remember, the maximum number of points of intersection you can have is 4. That's the maximum. You get all the way down to 0. Now, in having a curve and a curve, the easiest way to solve them is the elimination by addition method. Are there any there that you would like to see work? Any that you had trouble with? Any problems you want me to go over? Not?
Oh.
Let's review. Thorough, extensive review. Got that, Kathy?
Yeah.
Okay. The first thing we dealt with was a quadratic function. Quadratic function was in the form of f of x is equal to ax squared plus bx plus c, and again, a cannot equal 0 because you wouldn't have a quadratic. Now, we said that any function is a set of points. The set of points that make up a quadratic function is a parabola. And the parabola will be either inverted up and have a minimum point, or inverted down and have a maximum point. You can always tell which position the parabola will be in by the coefficient of x squared, the value of a. If a is positive, it's going to be opened up, have a minimum point. If a is negative, it's going to be opened down and have a maximum point. So let's take a look at an example. Let's suppose I have f of x is equal to x squared minus 2x minus 8. So there we have a quadratic function, and what I like to do is I like to graph it. So the first thing I have to do is determine if this function is going to have a minimum point or a maximum point. Well, you take a look at the coefficient of x squared, it's positive, so that says, hey, you're going to have a minimum. Now, to determine the x value of the minimum point or the maximum point, makes no difference. The x value of this critical point, the vertex, the minimum maximum, is always negative b over 2a. Remember, these are the same a, b's, and c's you had when you had the quadratic formula. So we get the x value of the minimum of this problem would equal a negative b. Well, b is a negative 2. So a negative 2 over 2 times a, which is 1. So what you come out with is 2 over 2, which is 1. So the x value of the minimum point is 1. Now, as soon as we find the x value of the minimum maximum point, we select the other values of x we want to use. Now remember, you are selecting these. Select whole numbers. Take the 2 whole numbers immediately to the right of this number. The 2 whole numbers to the right of 1 would be 2 and 3. You take the 2 whole numbers to the left of that number. The 2 whole numbers to the left of 1 will be 0 and negative 1. Remember, always whole numbers. If this was a fraction, if this was 1/2, 2 whole numbers to the right would be 1 and 2. 2 whole numbers to the left of 1/2 would be still 0 and negative 1. Okay? So always take the whole number. We now have to find their corresponding f values. In other words, what we have to find is f of 1, f of 2, f of 3, and so on. To do this, all we do is plug in the values we have for x into the original function. If x is 1, we plug it in. We have 1 squared minus 2 times 1 minus 8. That gives us a negative 9. If x is 2, we have 4, negative 4. Well, that cancels. We have negative 8. If x is 3, we have 9 minus 6 minus 8. Negative 5. If x is 0, we have 0, negative 8. If x is negative 1, we have 1, plus 2, negative 8 is negative 5. And there is the chart complete. There are other points we must find, though, in order to draw a fairly decent sketch. And these are the intercepts, where the curve is going to cross the y-axis. Well, when it crosses the y-axis, x must be 0. So if x is 0, you get 0, negative 8. Remember, the y-intercept is always 0, c. Always. The x-intercept. Now, in order to find the x-intercepts, and we normally have two of these, we let y equal 0. So if I take my given function, and I let y equal 0, I have 0 is equal to x squared minus 2x minus 8. This is a quadratic equation. We know how to handle this. We can factor it, complete the square, throw it in the quadratic formula. Either way, we come out with the same answer. I'm factoring this. We set each factor equal to 0. Solve, we get x equal 4, x equal negative 2. So our x-intercepts are 4, 0, negative 2, 0. Now all I have to do is locate these 8 points on our Cartesian system. So we're going to take our Cartesian system and plot these 8 points. Okay? First of all, I'm taking care of our chart. The first point in our chart is 1, negative 9. It says go over 1, down 9. Next point says go over 2, down 8. Next point is go down over 3 and down 5. Then we have 0, negative 8. And negative 1, negative 5. And there is our chart. Okay, now our intercepts. Our y-intercept is 0, negative 8. Well, we already have it. Our x-intercepts. This is where the curve is going to cross the x-axis. Well, it would be 4, 0 and negative 2, 0. So there are our points. Connect them up, we have our parabola. And there's the parabola. F of x is equal to x squared minus 2x minus 8. Okay? Any questions? Next thing we like to talk about is our variation problems. Now remember, we define the word varies as equal k. That's all it means, equal k. So let's suppose I have this. On the board I have a complete variation problem. It says A varies directly as B and inversely as C. If A equals 60, when B is equal to 12 and C is equal to 8, find A when B is equal to 18 and C is equal to 24. Now, in a variation problem, the first step is to set up the equation. Well, it says A varies. That means A is equal to K. Directly. That means what follows this word appears in the numerator of our equation. Directly as B. So we have KB. And inversely. That means we're going to have a denominator. As C. So this is our formula. A is equal to KB over C. The second step, we must evaluate the value of K. We must find what the value of K is. Well, they give you enough information. They say A is 60 when B is 12 and C is 8. Okay? Notice this is enough information to find out what K is. If I multiply both sides by 8, I get 480 is equal to 12K. K would equal 40. And there we have found the value of K. Step 3, we replace K by its value in 1. So 1 now becomes A is equal to 40B over C. And this is our new formula. With this, we can find anything we want given enough information. Well, it says, hey, find A. Find A when B equals 12. So I have 40 times 18 and C is 24. And there it is. 40 times 18 divided by 24. Well, you know how to handle this. Let's see, 6 into this goes 4 times, 3, 10. Your answer is 30. The answer is 30. And that is a complete variation problem.
Which one is it?
This one. It's a little harder than this one. This one's a very... But if you know how to do this one, you know how to do them all. The arithmetic might be a little bit more tedious, but the problem's the same. Okay. We then talked about identifying equations. Finding out what geometrical figure these equations represent. We had 7 of them. First we had a line. And we said a line must be in the form of AX plus BY equal C. In other words, in order to have a line, both x and y are first degree. The exponent and highest exponent we use for x and y are 1. Anytime all the exponents are 1, it's a line. So we have 3x minus 4y equals 7. This is a line. Notice x and y are both first degree, a line. The second geometric figure we had was a parabola. And the general form of a parabola was y is equal to ax squared plus bx plus c. This is what we just got done graphing, a parabola. Notice, in order to have a parabola, you have an x and y. Y is first degree, meaning the highest exponent we use for y is 1. X is second degree. Anytime you have this, it's always a parabola. Y first, x second. Yes?
Can that bx term ever be negative for a parabola?
Yeah, sure. A and B are real numbers. They can be positive, negative. Example, we're going to have y is equal to negative 3x squared, negative 7x plus 4. This is a parabola. What's this parabola going to have? A maximum or minimum?
Maximum.
Sure, maximum. See, it could be negative. Okay. Now, the next 5 all come from ax squared plus by squared equals c. And remember, to identify these, it must be in that form. The x squared and the y squared on the same side of the equation, the constant on the other. Well, we're going to have a circle. We get a circle when A, B, and C all same sign. .9% of the time they'll be positive, all positive. And A must equal B. What we're saying here is that they all have to be same sign, and the coefficient of x squared and the coefficient of y squared have to be the same. Example, 2x squared plus 2y squared equal 15. This is a circle. A, B, and C have the same sign. A is equal to B. We can have an ellipse. We can spell it, we will have one. Okay? Ellipse. You get an ellipse when A, B, and C have the same sign again. But this time, A and B are different. A does not equal B. Notice again, they'll all be positive, A, B, and C. But the coefficient of x squared and the coefficient of y squared are not the same. Example, 3x squared plus y squared equal 4. A, B, and C are all positive. A does not equal B, ellipse. Using the same a squared plus ax squared plus by squared equals c, we can have a hyperbola. Now remember, a hyperbola is just two parabolas facing each other, that's all it is. You get a hyperbola when A and B have different signs, opposite signs, and C does not equal 0. C does not equal 0. What we're saying there is that the x squared term and y squared term have different signs. And this number over here cannot be 0. It can be anything else you want it to be, but it can't be 0. Negative 4. Notice A and B have opposite signs. C is not 0. Okay? Now, with this same equation, we can come out with two lines. Remember, this is one line, but using this, we can come out with two lines. And we get two lines when A and B, different signs, and C does equal 0. An example of that would be x squared minus 9y squared equal 0. Lastly, using the same equation, we come out with one little point. Just a point. And we get a point when A and B, same sign, C is equal to 0. Notice, X squared plus y squared equals 0. This is a point. Now these are the 7 geometric figures you are responsible for. These are all we have at this time. If I have, yes?
Are we going to have to graph any of them?
No.
Identifying.
Just identify. Okay, so if I take a problem, say I have 3x squared plus 4y squared equals a negative 21. And I want to identify this. So I know it's not a line because I have squares in there. I know it's not a parabola because they're both square. So if it's anything, it has to come out of one of these 5. So we go through it. Circle. A, B, and C, same sign? No. Ellipse. A, B, and C? No. We're hyperbola. A and B have opposite signs? No. Not hyperbola. 2 lines. A and B must have no. Point. A and B, same signs. C equals 0. No. Nothing. If all your answers are no, there is no graph for it. None. Okay? Any questions on that? No, let me give you a helpful suggestion. I gave the other class, I might as well give it to you. I told you you're going to have 10 identifications. You got that? 10. Guaranteed there will be one of each. At least one of each. So if you want to make sure you get one right, just write circle 10 times. You'll get one right. Okay. Next. My gift to you. Determinants. We dealt with second order determinants, third order determinants. And we said a determinant was a square arrangement of numbers. A second order determinant is a 2 by 2 square of numbers. Example. Now, a determinant is a number system, and we have to find the value of this particular determinant. Now, in determinants, we have a positive direction, we have a negative direction. A second order determinant is very, very trivial to evaluate. Positive direction always start at the upper left, draw a diagonal. We come out with negative 16. Negative direction. We start at the lower left, draw a diagonal. Find the product of that diagonal. Now it's all arithmetic. We come out with negative 16 and a positive 30. The value of this determinant is 14. No one, got that, Tim? No one should miss that one. That should be an easy 5 points for everyone. Or 4 points, whatever it's worth. This one I think is 6 points, 3 by 3. On the board we have a determinant, a third order. We have to evaluate this. Now there are 2 ways to evaluate a third order determinant. One is called by extracting minors. I didn't teach you that method. I taught you, well, the first thing we do is we recopy the first 2 columns to the right of the right line. Remember, when you copy these numbers down, to be very careful. Students have a tendency to make mistakes by forgetting to put a sign or something careless. Now again, as we did in the second order determinant, we have a positive direction, we have a negative direction. The positive direction, we start at the upper left and we draw a diagonal. We find the product of that diagonal. Well, the first diagonal is 16, positive. We move over one. We draw a second diagonal. We find the product of that diagonal, which would be 0. Remember, anytime 0 is on the diagonal, the product of that diagonal is 0. We move over one more, draw the diagonal, find the product, which would be positive 3. And there is the positive direction. Negative direction, we start the lower left. Draw a diagonal. Find the product. That would be 0. Remember, anytime 0 is on a diagonal, the product is 0. We move over one. Draw a second diagonal. That would be positive 18. One more. Find the product of this third diagonal. It would be a positive 8. Now it's all arithmetic. We have a positive 19 minus, here we have a positive 26. Our answer is negative 7. Okay? So evaluating a second order and third order determinant, all arithmetic. We then went into systems of equations, solving equations, more than one equation with more than one variable. And the first type we came across was two lines, finding the point of intersection of two lines. Well, let's take a look. On the board we have two equations, both lines. We like to find the point of intersection of these two lines. Now, we have two ways to do it. One is the elimination method. The second is the determinant method. I am going to do this problem both ways. First of all, the elimination method. We have two equations, two unknowns. Our job is to get this down to one equation, one unknown. So what we have to do is try to get one of the variables to have the same coefficient, opposite sign. None of the variables have the same coefficient. The y's have the opposite sign, so I'm going to attack those. I'm going to try to get rid of the y's. That means I want to make their coefficients the same numerically. Well, the LCM for these problems would be 15. We want to make them both 15. That means I'm going to have to multiply the first equation by 5 and the second equation by 3. Remember, you multiply every single term in that equation by this number. If I multiply the first equation by 5, I have 20x plus 15y equal 80. If I multiply the second equation by 3, I get 9x minus 15y equal 36. Therefore, when I add these two equations, I come out with 29x equal 116. One equation, one unknown. If I take it, divide both sides by 29, I get x equal 4. So now I know the value of x. I have to find the corresponding value of y. So I go up to the first equation. I know now that x is 4. So every place I have an x, I put in a 4. I have 4 times x, so that'd be 4 times 4 is 16, plus 3y equals 16. We're solving for y, one equation, one unknown. We get 3y equal 0, y equals 0. Remember, this is an ordered pair. It's a point. 4, 0. Use the second equation to check it. 3 times 4 is 12. Minus 5 times 0 is 0. 12 minus 0 is definitely 12. This is your point of intersection. This point is on both of these lines. Now I said the second way we have is the determinant method. Now in the determinant method, the first thing you have to do is find what's called D, the general determinant. In order to find